Today is part 3 of the normal model. So how do we know if our data follows a normal distribution? So let's take the following data. We have 2, 5, 4, 8, 9, 7, 5, 1, and 2. What we want to do is we want to create z-scores for all of these. So we need the mean and the standard deviation. So I went ahead and found that for us. 4.777 is the mean and 2.819 is the standard deviation. So we're going to take each value, so let's say we start with 2, and we find the z value for it. 2 minus 4.777 divided by 2.819, and we get negative 0.98552. So that's our z-score, and we'll do this for each one of the values. And we're going to plot these, and on the x-axis is going to be our values, and on the y-axis is the z-scores. So what you'll see is hopefully a bunch of points, and we'll hopefully see that the points will follow approximately a line. So how do we do this on the calculator? We've put in our data into L1, and we're going to go to second y equals, so stat plot. We're going to go to option number 1 here. Okay, it's already on. And what we want to do is we want this one right here. Okay, so the 6th type, and we're going to arrow to the right until we get to it. Hit enter. Our data is in L1, so everything's fine there. So we're ready to hit zoom 9. And there's our data. So this is called the normal quantile plot or the normal probability plot. And what we're looking for is the data to be linear. Now it is not going to be exactly linear, but it's going to be kind of linear. And if it's kind of linear, then it's approximately normal. And that is the key word, the word approximately. So how do we know if our data follows a normal distribution? If the plot shows an approximate line, then the data is approximately normal. Now there are other ways to do this. You could create a histogram or a dot plot, but you'll notice that they don't really do a good job of determining if we have a normal distribution or not. So I typically recommend doing a normal probability plot.